The next kind of graph we're going to look at is called a hypercube, and the graph is almost, but not quite, as cool as the name. So we're going to define a hypercube for any number of nodes as long as that number of nodes is a power of 2. So here we have 4 nodes, that's a power of 2 squared. And what we're going to do is we're going to connect edges up in a particular way. And this is how we're going to do it. We're going to imagine that every node has a label, and that label is a bit pattern. In particular, and we imagine that we're going to number each of the nodes, basically from 0 up to n-1, and we're going to connect 2 nodes if their bit patterns differ in exactly one place. So we see this example here. If we label the nodes, these are now binary numbers, 0, 1, 2, 3, we connect these 2 nodes because they differ just in the first bit, 1, 1, 0, 1. We connect these 2 because they differ in the second bit, 1, 0, 1, 1. We connect these 2 because they differ in the second place, 0, 0, 0, 1. And we connect these 2 because they differ in the first place, 0, 0, 1, 0. And we can generalize this to larger graphs. So here's a hypercube on 8 nodes. Can we number the nodes from 0 to 7 in their binary bit patterns? And then we connect 2 nodes if they differ in exactly one bit place. Now, perhaps you can see why these are called hypercubes. This is a cube. The previous one was a square. What's the next one going to be? So to generate the hypercube for n equals 16, you can do this with a very, very interesting little trick. What we're going to do is we're going to take 2 hypercubes of size 8 and 8. Now 8 and 8 is going to be 16. Let's look what we can do. We can leave these bit patterns the way that they are, and then we can extend them. Everybody in this hypercube is going to get a 0 out in front. Remember what that means in terms of the binary numbers is that they stay the same. A leading 0 doesn't change anything. But this second hypercube, everyone's going to get a 1 out in front. Again, thinking about your binary numbers, what is that doing? It's adding 8 to all of the numbers of these nodes, giving unique bit patterns that we haven't seen before. And now if we connect the corresponding corners of these 2 cubes, which is going to be a little bit messy, and I can draw them deeper, but it'll start to make the picture a little distracting. That is a 4-dimensional cube, also known as a hypercube. We can keep extending this over and over again, 5-bit patterns, 6-bit patterns, 7-bit patterns, and each time what we're doing is connecting 2 hypercubes of the previous size, extending them, and then connecting the corresponding vertices.